Have you ever wanted to track your sleep during the night with a next-gen wearable, but found that it interrupted your sleep? That's what's happening to the four people that you see right here. The bulky wearable presses against their wrist and keeps them up at night. But what can we do to solve this?
Introducing the PillowTrack, a new innovative sensing platform that integrates with your pillow to provide unobtrusive ambient sleep sensing without interfering with your normal routine. PillowTrack differs from typical ambient sleep sensing platforms, like smart matches, in that it is easy to set up in addition to being low cost. PillowTrack uses a futuristic capacitive sensing to gauge your sleep quality and can provide a sleep score, just like all the other bulkier and obtrusive solutions.
But what is this capacitive sensing technology? For some quick background, a capacitor consists of two parallel plates with a dielectric material in between them. We can calculate a value called the capacitance, which is dependent on the dielectric, the area of the plates, and the distance between them. We can then associate the capacitance with a pressure or load. We measure capacitance on a microcontroller by connecting the sensing node with an LC tank and measuring the frequency of the signal's oscillation. We can then use the equation F equals 1 over 2 pi times square root of LC to calculate capacitance. In our case, we are using conductive textiles to create unobtrusive capacitors on the surface of the pillow and then map the load distribution on the pillow over time.
We can associate this data with sleep quality by considering several metrics. For starters, we know that deep sleep is characterized by minimal movement and slow breathing, whereas REM fosters micromovements. We can therefore classify these stages and track nightly cycles. From there, if the sensors detect movements during deep sleep periods, for example, it will count against one's sleep score. Additionally, our system will detect and count conscious movements, like raising your head, against one's sleep score. To begin, we created a 4x4 array of copper tape, which will serve as a capacitor plates, separated by a layer of foam tape to act as a dielectric. The four strips on one side overlap with the other side at 16 distinct grid points, each functioning as a capacitor. Once we get this 4x4 fully ironed out, we'll scale up to a 6x6 softer version to more closely mimic a pillow. We will be able to detect the position of one's head by monitoring the capacitance of each of the grid points. The higher the capacitance, the smaller the distance between the plates, and therefore the greater pressure applied in that area.
To measure the capacitance, we connect the leads from the rows and columns of our sensing array to a multiplexer, and then send those inputs into a capacitive sensing chip. From there, we can simply use I2C communication protocol to get the capacitance from this chip onto our microcontroller and then send that where we need it to go. When we send this data to our computer, we can create a heat map GUI, which shows the location and intensity of pressure over time.
For future tasks, we hope that the PillowTrack can be improved to incorporate a microphone for multimodal sleep sensing to detect snoring and nocturnal sounds, and a larger sensor array for higher resolution tracking of height, position, and movements, enabling richer sleep analytics and personalized insights.